Okay, so another application of your virtual work method is for the deflection of frames. So basically, yung equation na gagamitin natin sa frames is a combination of the equation that we used for your beams and truss. Because frame is both subjected to bending and axial force. So applicable yung parehas na equation. But yung pinaka kino-consider lang natin sa deflection ng frames is the bending equation or itong first part. But unless stated sa problem, because there are cases na gusto i-consider yung axial deformation, we need to use this equation or yung equation na ginamit natin sa truss. But yung general equation niya is the combined equation of your bending and axial. Pero ito, unless otherwise stated in the problem, the effect of axial deformation is negligible. Because most of the time, super maliit lang naman yung effect ng axial deformation. So, nineglect na lang natin. Then, procedure. Same lang yung procedure. Real system, then virtual system, tapos yung per segment. Kukunin mo yung MP, MU. Kung may vertical, kung may axial deformation, kukunin mo rin yung FP tsaka FU. Okay. So first, determine the rotation of joint C of the frame shown. Yan. So, determine the rotation of joint C. So rotation, ang ilalagay natin is a unit couple. Again, same lang nun. First step is, tingnan nyo muna kung ilang segment ba nahati yung frame. So, ang first or unang member is member AC tapos member CD. Kung mapapansin nyo yung member CD, isang segment lang siya. Yan, segment CD. Yung member AC, nahati siya sa dalawang segment because of your 40. So, meron tayong segment AB tapos segment BC. So, therefore, we need to have 3 equations. So, segment AB, segment BC, tsaka segment CD. Now, unahin natin yung virtual work. So, yun. Lagay tayo ng 1. Tapos, after you add the slope or the unit load couple, compute for the reaction. And then, cut natin. So, here, papansin nyo, no? Wala tayong horizontal force sa segment AC. No? Ang meron lang tayo is axial. Diba? Now, paano nyo ba siya mako-consider? Baka ma-confuse kayo. No? Paano mako-consider siya? Sorry. What you need to do is, assume this as parang pinatayo nyo lang yung beam. Pag ipapahiga nyo siya, ganito yung itsura niya. A, C, tapos B. So, assume nyo lang na pinatayo yung beam para madali yung pag-visualize nyo ng cut ng X. Tapos cut ng X. To get your MU. Now, if you notice, ang forces na present is an axial force. Wala tayong perpendicular sa member. So, ang MU mo is equal to ilan? Ito yung MU eh. May makukuha ka bang moment? Wala kasi axial force. So, 0. 0. 0 yung axial force natin. Yeah. Check natin. Sorry. Yung 0 to 12, 0. Segment BC 0 to 12, MU is also equal to 0. Diba? Kasi kahit maglagay ka dito ng MU, walang perpendicular force na magkukos ng moment. So, 0 siya. So, pwede pala siya na 0 yung MU mo. That is if walang perpendicular force or force na perpendicular sa member. Okay lang naman yan. Check natin. Ganito. Kung segment ano naman, segment CD, ganito yung itsura. So, mas maganda yung cut dito. So, yan. Then, MU. Now, here, may value na yung MU natin, 1/30x. Now, in this case, since 0 na yung segment A, B, and BC mo, yung MU, kung i-multiply mo yun sa MP, of course, ang sagot niyan is 0, di ba? So, it's okay na wag nyo nang i-compute yung MP for segment A, B, and BC. Kasi kahit i-compute nyo yan, pag i-multiply nyo sa MU, 0 lang din naman. So, at para wag nyo nang pahirapan yung sarili nyo, wag nyo nang i-compute yung MP for segment A, B, tsaka BC. Kasi ma-eliminate lang naman sila. Kapag nagsosolve kayo ng problems, no, na in case, for example, yung MU nyo o yung MP is 0, wag nyo nang i-compute yung counterpart nila para mas madali and mas mabilis. Yan. Dito kasi kinompute pa, no? So, I suggest wag nyo na itong i-compute kasi pag i-multiply nyo naman, mag-0 na lang naman yan. Segment CD na lang. So, ito, compute natin. So, yun, we have 38.5x minus 1.5x times x over 2. So, yun. Then, substitute. Ayan na. 0 to L. Hindi na nga to sinama. Kasi nga, ang MU mo is 0. Kung mapapansin mo, segment CD na lang yan. 0 to 30. Ito siya. So, MU, MP, tapos 0 to 30. Wait lang. May di ata ako napansin. Ayan. Sinsolve natin. And then you will get 6487.5 kips per. Sorry, this is square. Ba't ba ito naka-ano tayo na? This is square po. Pakiayos na lang. Square. And then kaya yun, 12 squared naman yung nakalagay dito. Ito lang na error. Over EI, so you will get 0.0129 radian. Now, anong ibig sabihin na positive yung sagot? Ibig sabihin yung rotation, pati dun sa previous problem, ibig sabihin yung rotation na in-assume mo, ganun yung tama yung assumption mo. So, magiging somewhat ganito yung deformation niya. Kapag negative yung sagot, ibig sabihin, mali lang yung assumption mo, so ang magiging deformation niya siguro is ganito. So, yung negative sign, always, no, ano lang siya, tawag dyan. That's just the assumption of the direction of that deformation. Now, in this problem, no, hindi natin consider yung actual deformation since hindi nakastate sa problem. What we considered is just the bending moment equation. Ito, try natin. Use the virtual work method to determine the vertical deflection at joint C. So, vertical deflection, so replacing these loads with just a unit load 1. Now, take note, first step, di ba? Check natin kung ilang segment. Obviously, isang segment lang to, AB. Ito naman, isang segment lang din, BC. Kasi wala namang hati. So, yun. And then, apply the unit load 1. Yun. Tapos compute the reaction. And then, since 2 segments, so dalawang cut lang din yung gagawin natin. Dalawang cut lang. Ito, cut ka dito ng X. Tapos cut ka dito ng X. Yan. Now, since kung papansin nyo yung 1, no, hindi siya naka-perpendicular sa member. So, what you need to do is compute for the components of this one. Madali lang naman yung pag-compute, no? Since given naman tong dimension ng part segment BC ng beam, ako-compute natin yung deflection, yung component or yung angle. Okay, so to compute that, tingnan natin. So yan, sa segment AB muna yung una. Here, di ba, mag-compute tayo ng MU. So your MU is equal to -4 kasi wala ka namang perpendicular force, -4. Next is segment BC. Ayan. So, ulitin ko, dapat yung perpendicular sa member yung kino-consider natin. So, saan galing yung 4/5 tsaka 3/5? Wait lang. Erase ko to. May magnifying tool ba ito? Ayan. Yan. Wait lang. Balikan. 3, 4, 5. So, this is 3, 4, 5. Hindi ako pwede magsulat pag naka-magnify. Sige, wag na. Ayan. So, if this is 3, 4, 5, and this is theta, di ba? Similar lang yan kapag nag-draw tayo ng perpendicular line dito. This will be your theta, di ba? So, theta to. So, if this is theta, ang adjacent is yung vertical component, di ba? Adjacent, katabi ng theta is 4/5. So, to get your adjacent, we have 4/5 times 1, which is 4/5. Yung opposite naman, which is this one, opposite the direction of the theta. Diba? Ito, equal lang yan kapag nandito sa opposite. Parehas lang yan. So, opposite ng theta is 3 over the hypotenuse 5. So, 3/5 times 1 will give you 3/5. No? Kinonvert lang natin yung 1 into its components. Kaya naging 4/5 tsaka 3/5. Now, itong mga to, these are the reactions. Now, if you don't want to solve this, much better na mag-cut tayo dito na sa free end. Dito na yung cut para kahit wag nyo na itong isolve. Wag nyo na itong pansinin. So, dito na lang tayo sa side na to. Tapos, this will be your MU. No? So, if you'll notice, ang perpendicular force lang sa member is 4/5. Yung 3/5 axial force yan. So, wag nyo na siyang pansinin. So, yun. Magiging 0 to 12, 0 to 12, MU is -4/5. Di ba? Ito na yung rotation. So, dun tayo. Itong isa, this is a fixed support na free end yun. Huwag kayong mag-compute ng reaction sa free end kasi wala nga yung support. So, yun. Ayun. Dito, yun yung cut. Axial force tapos moment, MU is -4. Tapos dito sa kabila, ito lang 4/5. So, 4/5/x. Ulitin ko na, ang moment lang na i-consider natin is the force that is perpendicular or 90 degrees dun sa member. Dito walang perpendicular force, kaya yung moment 4 lang na-consider. Check natin. Now, sa real beam naman, yung cut natin sa una is ganito, di ba? So, this is your. So, ito naman. Now, in this case, nagkataon, yung 12 kilonewton meter is perpendicular na sa member. So, you don't need to compute for the component. Ayan, no? So, to get your MP, mandali lang. So, 76x minus 530. MP. And then, yung 76 kasi 90 degrees perpendicular sa member. Para di kayo ma-confuse, always remember, yung mga forces na perpendicular sa member, yun yung nag-create ng moment. Next, ito naman, perpendicular naman siya, 90 degrees siya sa member. So, you don't need to get the components. Ayan na. So, MP is -12x². And then, just substitute. 0 to 12, tsaka 0 to 30. MPMU, MPMU. Check natin bakit yan. May 1/2 because this is 2i. Kung bupansin nyo 2i, ito i lang to. So, we need to add the 2 dun sa segment AB. Ayan siya. So may 1/2. Huwag kakalimutan kapag non-prismatic, kahit yung frame, dapat included sa equation. Segment AB. No? Tapos segment BC. 0 to 5 ba talaga? Para mali ako. 0 to yan, 0 to 5 tama. Tapos 0 to 5. Bakit 5? This is 4, this is 3. Ang kino-consider natin is yung length ng member. So 5 meters po. So ayan. Substitute and then convert meter to millimeters. You will get the deflection or the vertical deflection at point C is 107 millimeters. Okay. So ito naman. Ito, considering the strain energy, so consider na natin yung axial deformation kasi nakastate sa problem, no? Associated with both the axial and moment, compute the horizontal deflection at joint C. So, una, bilangin natin yung segment, no? Isa, segment CD, no change. Tapos, segment BC isa, dalawa. So, may tatlo ulit tayong segment. Segment AB, 0 to 6. Segment BC, 6 to 15 or 0 to 9, up to you kung saan kayo magre-reference. And then, C to D, 0 to 18. Now, ang tanong, horizontal deflection at point C. So, i-replace natin to with a unit load. 1. Yan, unit load na 1. Tapos, sorry. So, yun yung mangyayari. Then, in this problem, ang reference point is A lang instead of... Kasi ang maganda kasi dun sa magre-reference point ka sa A, kasi pag, di ba, sa pag-drawing ng shear and moment diagram ng AC, for an example, magko-compute ka ng reaction sa C. So, to avoid computing for the reaction here, mag-reference point na lang kayo dito sa A. Para hindi nyo na-compute yung reaction sa C. Mas madali. So, after applying the 1 kips, compute for the support reactions. And then, cut natin yung segment AB. Ayan. Tapos, ang perpendicular lang na force is yung 1 kips. Ito lang. So, siya lang yung nag-create ng moment. So, 1 times x, positive. Now, according to the problem, consider the strain or energy or the axial load. Ang axial load po is the load that is in line with the direction of the member. Like your 5, 6, na direction in line with the direction of the member siya. And intention, so positive. So, ang FU natin, ikakopy nyo lang, ganun lang kasimple. Copy nyo lang yung FU, which is 5, 6. Next naman, segment BC, 0 to 15. Similar lang, no? Ito din ang cut. Ang value ng MU nyo is the same, 1 times X. Ang FU nyo is same din, 5 over 6. So, ito, kinapi lang. Same lang sila. So, 0 to 6, tapos 6 to 15. Ulitin ko na, kung naku-confuse kayo dito, pwede naman na i-portray nyo sa as ganito para di kayo ma-confuse. So, meron ditong 5 over 6. Tapos, meron daw na 1 kip. Tapos, this is 15. Kung na-confuse kayo yung nakatayo, tapos magka-cut kayo dito ng X, tapos magka-cut pa kayo ng isang X. Dun sa 6, tapos 9. Na? So, same lang yung makukuha niya. Kung malito kayo nung pahigaan nyo na lang yung member. Kung mas nasanay kayo sa kuha ng moment equation sa beam. Segment CD, sorry, may segment CD pa pala. Ito, so di ba nag-cut? So, MU is 5 over 6 times X. Now, here, wala tayong FU. Diba? Walang axial force. So, FU is equal to 0. Now, sa real beam naman, ayan. So, ito yung MP. So MP is, ito yung perpendicular force. Again, ito yung i-consider. So 24x ang MP. Ito naman yung FP. So yun, 24x, 8. Now, kapag andito naman yung cut, ito naman yung MP natin. We will have 24x. Tapos ito, this will be 6. So this is x minus 6. No? So 24x minus 24 times x minus 6. Tama ba? Tama. Tapos, since pwede mo naman siyang i-simplify, diba? So, negative 24x plus 144. So, yun. Ito yung matitira. Plus 144. Kasi negative. Tama ba? 24x minus. Tama. So, yan. Then, yung FU natin, FP, sorry, ba't ito? FP is equal to 8. Sorry about that. Di ko na na-edit. This is 8. Yan. So, segment CD. Sorry, nakakalimutan ko. Segment CD, MP. So, 8x. Ang FP natin is 0 since wala naman siyang actual force. Ulitin ko, actual force in line with the direction of the member. No? Ang moment, nag-create ng moment is yung perpendicular or 90 degrees. Yan. So, virtual expression, paki-substitute na lang. 0 to 6. Ito. Segment AB. Segment CD. And then, segment AB, segment BC, and segment CD. Now, ito yung, do not combine, no? Dapat separate sila. So, ito yung una. Ito yung sa bending. Itong pangalawa naman, tatlo din yan. Ito yung sa axial deformation. Bakit hindi ko combine? Kasi magkaiba yung unit. Ito naka-over EI. Ito naka-over EE. So, dapat, ang magiging final answer nyo ito. Itong dalawa. And then, after nating makombine, ito na nga, saka nyo isa-substitute yung value ng EI tsaka AE. So, solving now, substitute nyo na yung value ng EI tsaka AE. Saka na natin siya i-combine. So, final answer is 2.8032. So, for example, no, hindi binigay yung value ng EI tsaka AE. Ang magiging final answer na natin is ito lang. Hindi siya combined, no? Kung hindi to binigay. No? Kung hindi yan binigay. But since binigay siya, substitute na natin. If not, this will be your final answer in terms of EI tsaka AE. Na? So, I hope that's clear. No? So, ang important siguro sa virtual work method is marunong kayong mag-identify kung ilang segment ba yung nasa isang beam. And then, you need to be able to get the moment equations per segment correctly. So, if nako-confuse kayo doon, I suggest that you practice solving different types of beam with different types of loading and try to get the moment equations per segment. Kasi ito yung pinaka ginagamit eh. And then also, yung reactions, pinaka-important, please double check always. Okay, so that will be the last example for your frames.